Hi and welcome to this video about creating a simple COM server. In the previous video we've seen some aspects of client programming in terms of COM. How do we create a COM object by calling the co-create instance function, for example? And we've seen what that looks like behind the scenes from a client's perspective. In this video we'll take a look at the other side, which is the server. In this case, server implemented within a DLL. So here's a quick recap and what we want to do in this video. So first, when a client calls co-create instance, we get to this location in the registry, looking at the class ID under HKey classes root. If it's found, there should be an import server 32 subkey there, assuming it's a DLL. I'm going to assume that for the purpose of this video. If this is the case, the path to the DLL is going to be stored there in the default value, and then the DLL is going to be loaded, and DLL get class object is going to be called on that DLL, which is supposed to return a class factory. And then that thing is being returned back to the client. So the class factory is another kind of COM object that implements an interface called iClassFactory. This is the classic interface for creation. It could implement a custom interface for creation. It doesn't have to be iClassFactory, but this is practically the most common case, and co-create instance in fact assumes that. And so the class factory is going to be invoked by the caller using a function in iClassFactory called createInstance that will cause the class factory to create the actual object. What we'll create is an object of type called RPNCalc, which is going to implement a reverse Polish notation calculator. I'll explain briefly what that means very soon. And then that interface pointer, in this case called IRPN calculator, is going to be returned back to the client. The client can do stuff with that calculator. Of course, using the same factory, we can create any number of objects that we want. So that's the basic idea, and what we want to do here in this video is to implement this server side of things, that is the DLL itself, that has an implementation for a class factory and the actual COM class we're interested in, from which many instances could be created by various clients using this DLL. And this should be done, of course, using COM APIs. So that's the idea. Let's see if we can get that to work. So the first thing I'm going to do is to create a new project, and that project is supposed to be a DLL. I'm going to use the Windows Desktop Wizard template because it provides me with some nice options I can use. So let's call that RPNCalc SVR. That's going to be the name of our project and also the name of our DLL. We can put it somewhere here, and I can give the solution a different name if I so desire. It doesn't really matter, but let's call that RPN calculator to be slightly nicer, because we'll have to add at least one more project in order to create a client for at least testing purposes. So what I want here is a DLL. It's not very difficult to take an executable and turn it into DLL by changing some project properties, but let's have Visual Studio do that for us. I'm going to add a precompiled header to make it easier and faster to compile the project slightly, and I think that should be good enough. Maybe we can export some symbols just for fun. Let's go ahead and do that. We'll have to export something anyway. So here's what we get. The first thing we see here is the DLL main function. DLL function that every DLL can have. In this case, we don't really have anything very interesting to do here, so I'm not going to bother looking at that, at least not right now. So what we have here, beside that, we have this file here that has a few examples of exporting some information. Here's a variable being exported, which we don't care about. Here's an example for a function being exported, and even some class member being exported here. If you look at the header files, we can see here we have the precompiled header here, which is practically just including this framework.h. So we have this indirection, which just doesn't really mean that much. I'm actually going to remove that and paste it here. Just I don't like this framework.h, which doesn't really contribute anything to the project. Let me just remove that. And then we have the header file here, which just has some macros and some examples of the headers of stuff we want to export. In this case, I don't really care about all these things. I'm going to remove it. In fact, maybe I should have created an empty project to begin with. Anyway, we can start with that, even though it's not that much. So we have here this framework. Let's just build this for now to make sure everything compiles. So it compiles, but obviously the project is very dull, doesn't really have anything interesting. So the first thing we want to do is to create our own class. That would be the RPN calculator. Let's just create a class here. Let's call that RPN calculator. RPN calc, maybe slightly shorter. Let's go with that. So here's a little class. Now this is a C++ class. I need to turn that into a COM class. To make it a COM class, we have to do a few things. One of them is to implement a bunch of interfaces. One of them, of course, must be IUnknown, but then we also want to implement some useful interface, in this case something like IRPN calculator. Interface names typically start with a capital I. This is the convention used in Windows, but it's just a name. You can call it whatever you want. And you might recall that everything in COM is based around GUIDs in terms of identifying entities such as interfaces, classes, and so on. So we need another header file that we can use here. In fact, let's take this header file right here. And what we'll do is define some interfaces we'd like to use. So we have an interface called IRPN calculator. This is just the name we're going to use. It doesn't really matter. The important point is that it derives from IUnknown. It must extend IUnknown. And for that, we'll need to add some header files, maybe something like unknown.h at the very least, to have the definition for IUnknown. And then we have to provide the interface itself. What is going to be within this interface? In order for that to actually be something that is properly an interface, we have to create here a bunch of pure virtual functions. So first I want to explain what an RPN calc is. So for example, when we think about mathematical expressions such as 1 plus 2 times 3, we know that in order to calculate that, we have to first multiply 2 by 3 because multiplication has a higher precedence, then add the 1. And we're using here something called infix operators. Infix operators is what we're used to mostly as humans, because it seems easy enough, or it's something we simply are used to. But in fact, behind the scenes, the compiler will probably change that to something different, and it would be something like do a plus operator with 1 and the multiplication of 2 and 3. And essentially, the way you could calculate that is by pushing 2 onto some stack, pushing 3 onto a stack, and then you have a multiplication which will pop 2 items off the stack, make the multiplication and push the result back on the stack, and then the plus operator here is going to take this 1 and whatever is on the stack right now, again pop both of them, make the calculation, push the result back. In fact, if I would like to write it properly, it will be something like this. I can do 1, 2 and 3 and then multiplication and then plus. So every number is going to be pushed onto the stack. So we have 1 being pushed to the stack, then 2, then 3. Then multiplication will take both of these and replace that with a 6 and push that onto the stack. And then the plus will add all these 2 and push back the result on the stack. So this is what we're going to get here. In fact, this is how typically compilers compile that kind of code. And some languages actually work in exactly this way, like Forth, which is very well known for this kind of way of working. So anyway, we'd like to create this IRPN calculator interface to mimic this kind of functionality from a conceptual perspective. Remember, this is an interface, so we'll have to implement that, of course, properly. So the first thing we'd like to do is, since it's COM, we want to always return H result, indicating success or failure. Every COM function has to be with the standard calling convention, which is important for 32-bit applications. It's just part of the standard. It's a way to indicate how parameters are passed to functions and who is responsible for cleaning up the stack for parameters passed on the stack. And let's have one function called push, which is going to really add a number onto the stack that we need to manage here. So it's a pure virtual function. Obviously, we need to have the opposite function as well. So I'm going to have a pop function here. And since I have to return something and H result is the official value to be returned, I'm going to have like a pointer here in order for me to indicate to return the actual value. And then we can have other operations such as the add operation. So the add operation doesn't really need to accept anything because it's supposed to pop the 2 items that we have on the stack, if of course they're available, add them together and then push the result back on the stack. And so we can definitely do the same thing with other operators such as the 4 classical operators. Let's go with those. We can have other methods if we want to, for example, checking whether the stack is empty and things like that. We can do that. Let's go ahead and do that. So we have, let's add another, just the last item here. Let's call that is empty. And again, since we don't have the ability to return something with the H result, it's better to use something else. So that's going to be whether that's empty or not. So we have this interface. Okay, great. Now we can implement it. Okay, so now we have our class, RPN calc. We want the class. Let me include here RPN calc server. We want to implement the IRPN calculator interface. That's the first thing we need to do here, because we want to have that functionality available to us. So I can allow, or at least ask Visual Studio to help me out by using control dot here on the class name and ask it to implement all pure virtual functions for me. And hopefully it will do that. So here goes. We can see that it just read the information and just provided the same functions here with the override attribute here for C++ 11 and later. And you can see there's no equals 0 here. We have to actually implement that. Let me put here this in public, but doesn't really matter because it's going to be called indirectly using an interface pointer. But the actual implementation, of course, is in the CPP file. You can see everything here just has this return in not impl, which is a standard error value indicating there is no implementation. Okay, so now let's go ahead and implement the stuff that we really care about. And so what I want here is to have some kind of stack of sorts. So we can use the real or an example of the stack class, say from the C++ standard library. We can use that, or you can use a vector, or you can use a fixed array, whatever you want. In this case, I'm just going to use integers here. We could use doubles or other kinds of types. It doesn't matter, feel free to play with that. Let's call it M stack. So we have the stack here. And now we can start implementing what we really care about here, which is the stack operations and the mathematical operations. So push here is going to take the stack and push the value and return SOK. If we have pop here, we have to make sure that the stack is not empty. So if it is empty, then we're going to return E unexpected here, an error indicating that call was unexpected at this time. Otherwise, we can pop the value by looking at the top and then popping the value itself. So that's how the C++ stack works. So we need to call the top to get to the top of the stack, and then we actually have to pop the value so it goes away and removed from the stack, and then we can return SOK. Well, not really. We need to pop that inside N. Technically, you could do other checks, such as to make sure that the pointer here is not null and stuff like that. But I'm going to skip that for brevity and to make things slightly easier to read. And then we have the operators themselves. And of course, we have is empty. Is empty is fairly straightforward. So let's start with that. So is empty is whether we have our own stack and see if it's empty. If it's empty, if I can type correctly, and of course dereference that, and we're done. Again, not going to check the pointers here. Now, how would we do the add and the other operators? So first thing we need to do here, we have an X and Y we want to work with. So we need to make sure that this works. So we have enough items on the stack first, so we can check that. So let's say if we have our stack here, and its size is less than 2, then of course that can't work. Let's go ahead and return unexpected here. Otherwise, we can go ahead and call pop with X and pop with Y, and just return by calling push with X and Y, like so. X added to Y. With the same idea, of course, we can just go ahead and copy that for most operators. So for this one, we're going to do Y minus X, because that's going to be the second one we pop. It's supposed to be the first one that we need to use as the value to subtract from. And then we have multiplication. In this case, it doesn't really matter. The order here goes. And finally, we have division, which is probably the trickiest. And so in this case, we need to pop the values, and then we can, before we return the result of Y divided by X, we have to verify that X is not 0. So if it is 0, then again, we can say something like unexpected or whatever. And that's it. We're done in terms of the real stuff we wanted to implement, but unfortunately, that's not really good enough. We have to also implement the COM stuff. So first thing, we have this add ref and release to manage the lifetime of the COM object. So I'm going to add a reference count here. So let's add a reference count here. Let's initialize that to 0, maybe to 1. It's unclear at this point, but let's start with maybe 1, and we'll see if we need to change that later on, because we don't know just yet who is going to actually create instances of this RPN calc. So let's use add ref here. Add ref is going to be very simple here. So I'm going to add to the reference count. In this case, with release, it's a bit tricky. It's trickier. So we need to take our reference count and decrement that. And if count is 0, we're going to use delete this here to do the sort of suicide committing suicide of the object, which means that's going to be allocated using new somewhere. We don't see where that is just yet because it's part of the class factory we'll implement later, but we have to start somewhere. So I'm going to assume that I'm going to delete the object when the reference count drops to 0. Notice here I'm returning count. Does that cause a problem in case count is 0? So no, it's not a problem because this is a local variable. I'm not returning mref count. That would be a bad idea, because after delete, mref count doesn't exist anymore. That could cause an access violation or returning some kind of garbage value, both of which I don't really want. That's why I put that here in a local variable. Another thing you might be worried about is the concurrency. What happens if we have multiple threads calling add ref and or release? We need to perhaps protect this plus plus and minus minus from concurrent access. This is in fact correct. In general case, this is correct, but I'm going to keep it simple here and assume that add ref and release are going to be called by one thread at a time. We'll deal with perhaps a more complicated case in a separate video, but for now we'll keep it as simple as possible. The most interesting function to implement in terms of the IUnknown stuff is the query interface, the query interface method. So in this case, we have to return the correct pointer to ourselves if we implement the interface that is asked here. So if the interface here is the ID of IUnknown, so we have this association between an interface and its identifier, its GUID, because of the declaration specify UID, which is supported by Visual Studio. We can also use the ID IUnknown, which is also provided as some global variable. It's the same thing. Or we need to look for the other interface, which is the interface ID for IRPN calculator. But that doesn't really exist because we didn't create any. So we need to go back here to RPN calc server, and we need to also create here a GUID for this interface. So we need to go to Visual Studio Tools menu here. We can go to the Create GUID tool. Here's the Create GUID tool that generates a new GUID every time you run it. And then you can create more GUIDs by using this new GUID button. You need to select some kind of format here that would make sense. I can try using a defined GUID here, which could work. We can use the static const GUID, which also would work mostly. And but we have to be careful here for linker errors. And we can also use the registry format. Let's go with that. Let's try that. I'm going to add the declaration specifier here with UID and provide this GUID, like so, to make it easier to use this thing that we've seen, where we use UID off operator. So I need to just put it in the correct location. Should be here, like so. We remove the properties window here, something like that. We'll see another brace here, and now if we have that kind of declaration, it makes our life slightly easier. We can use UID off attribute and use RPN calculator here, like so, and that's going to use that structure behind the scenes generated by the compiler for us. So if this is one of those interfaces, let's go ahead and make this UID off as well for consistency. If this is one of those, we support them. Otherwise, we don't support them and we return in no interface. If someone asks for something else, we don't support that right now. And so now we want to return the actual result. So we have to put the actual result into this PPV object, the one that is provided here as the output parameter. That's going to be us. So we're going to static cast here to IUnknown or to RPN calculator is the same thing because we're part of the same V table of this. You can also get away with just passing this, which would work in this simple case because this also starts in the same location. But if you have multiple interfaces implemented, you have to be careful to use the correct interface branch, because in that case you would have multiple virtual table pointers and multiple virtual tables. Unfortunately, I can't go into that in more detail in this video. And the last thing I need to do here before returning SOK is to call addRef. So we have to call addRef because now we have another interface pointer we have provided to someone, and I'm going to return SOK here indicating this is fine. I have support for that interface and both of these interfaces. So far so good. We have our class. It's fully implemented, even though we haven't tested anything just yet. The next step is to provide a class factory. Let's go ahead and do that. I'm going to add another class here. Let's call that RPN calc CF for class factory. So why do we need a class factory? This is because of, again, something that COM requires. It requires a class factory, which is a way to provide a factory to create other objects. This provides more flexibility, but regardless, we have to build some kind of class factory. We'll build the minimum one we can get away with, which implements the iClass factory interface. So here's iClass factory. And again, if we don't see everything here as we expect, we might need to add some includes, such as IUnknown, which is fine. And in fact, I think it won't be actually a problem once we do that stuff from the C++ file, but let's just use it in this way. And then we need to implement the iClass factory interface. So let's go ahead again and do a control dot here and let Visual Studio provide the bare bones of these implementations. And what do we need to do here? So we need to do something very similar in terms of the IUnknown part. This is the part of IUnknown. But in this case, I'm going to do something slightly different. Instead of managing some reference count, I'm going to return some fixed values here as long as they're not 0. Why? That's because I'm going to create later the class factory as a singleton object. So it's going to be allocated statically rather than dynamically. So, and that's because it's very convenient, since a single factory can create any number of instances, really. So it doesn't really matter. It makes our life slightly easier when making this implementation. What we really want to implement, what we really need to implement, is this create instance function. This is where we actually create a new instance based on the interface ID requested here and returning the interface pointer here if indeed it is supported. So first, let's add and include to RPN calc. So we have our class there, and now we can create this calc thingy by using new. So I'm going to create this RPN calc here, like so. And so the second thing to do is to ask the object whether it supports this actual interface being requested. Maybe the interface being requested is not IUnknown, and it's not RPN calculator, maybe something different. So we have no way of dealing with that. So I'm going to ask the object instead of trying to figure it out myself, which I can because I have that information, but it's better to let the object give me the result. So I'm going to say query interface. Here's the interface that the client is requesting. Here's the location for the result. Just go ahead and put the result there. Like so. In fact, we can take the H result here and see what's going on. Now, after the H result is provided to us, the query interface here either succeeded or failed. We're going to return that H result. But there's one thing we have to do first. And that something might seem very weird at first, but in fact, it's the right thing to do. So I'm going to take calc here, I'm going to call release on it. Let's see what happens here. When we create a new object, notice the constructor here is going to set the reference count to 1. So now the reference count here is 1. Let me write it here, is 1. Then we call query interface. What happens after that? Ref count is going to be 2 if successful. But if it's not successful, it's going to remain as 1. So now when I call release, what happens? If successful, then ref count is going to drop to 1. Otherwise, object will be destroyed. Exactly what I want, because the query interface call failed. because once we have a call to release, release will decrement the reference count by 1 to bring it down to 0 and destroy the object. So that's kind of perfect way, or as perfect as we can muster here, in order to release the last interface pointer here, if indeed query interface failed. If it succeeded, then great. The reference count is exactly 1, which will then return back to the client. The first parameter here, which I didn't mention, is called the outer unknown, and this has to do with a feature called comma aggregation, which is beyond the scope what we can cover here, but in most cases it's going to be passed as null. You might recall that parameter is part of core-create instance as well. There is an unknown outer there, and usually we pass null, but in case that we want to aggregate the object, we have to pass something else. In this case, the particular object has to be built slightly differently. It has to be prepared to be aggregated, which is, like I said, beyond what we can cover here. So I'm going to assume no aggregation. In fact, we can even check that and say that if the unknown outer is not null, then we're not able to accept that. So maybe we can return something like not aggregation or something like that, indicating that not aggregatable or something else. Maybe just use invalid arg or something, indicating that we don't support aggregation. We only support creating the object independently without being aggregated. So at this point we can build. Let's see if everything goes as planned. For now everything looks fine, but still we're missing the full pieces of the puzzle here, because we have the class factory creating the instance. That's great, but who is going to create the class factory? This is the thing that is currently missing in order for us to be able to connect at least some of the dots here. And this is something we're going to do right now. So we're going to go to maybe to the global part of the application. And so as you recall, we have this function that has to be called DLL get class object that every DLL must implement. If it doesn't implement that, then something is wrong and you can't, it's not a COM DLL. And so we can look at this function, see what that is supposed to look like. Let me bring up the documentation here and see what that function is expected to look like. So here goes. Let's go ahead and paste that, see if we have something about that. You can see it returns an H result. It also has the std calling convention and accepts a class ID, an interface ID, and returns a pointer. So it accepts a class ID, a reference to a class ID. This indicates the actual class we'd like to create, because our DLL might support multiple classes. And then we have the interface for creation. So that's going to be the interface for creation, which we expect to be iClass factory, but in theory could be something else. And then, as usual, there's a location for the result, where to return the result, and we have to implement that. So I'm going to have here our class factory, and what I'm going to do here, I'm going to use a static object here for RPN calc_cf. This will make it easier, and that's why we implement addref and release in a very particular way, so that we don't have to manage the object lifetime, because we just need a one class factory. So what should we do next? First thing we have to do is check for the class ID. Are we getting a request to create something that we know how to create? What should we put here? Should we put something like the interface ID of RPN calculator? No, definitely not. This is an interface which could have many implementations. We need one specific implementation we are implementing here. This an interface, something we can publish to the world, and many implementations could be created. And now we have to select a specific implementation in mind, which means that we actually have to define another GUID here. We have to provide another GUID here indicating the GUID for the class. So I can use again this declaration specifier trick and give it some kind of name, like I don't know, RPN simple calculator. Whatever name. Again, the name doesn't really matter. What matters is the GUID. So notice this structure has no implementation. It's not really about implementation. We have the implementation elsewhere. We just need to be able to identify the implementation in some way. We can give it, in fact, the same name. We can provide a GUID here under RPN Calc, but to make it easier to put all the interfaces and GUIDs in a separate file. So all we have here are just declarations without true implementation. We need a new GUID. Let's go ahead and generate one. Let's use new GUID and copy again. So now we have a new GUID. Let's go ahead and paste it. Like so. Remove the curly braces, which UID operator here doesn't really like. And now we can move back here and ask to compare with the UID of RPN simple calculator. If it's this one, we can talk. If it's something else, then we can return the standard error indicating class E, class not available. So it's essentially saying you are looking for some implementation which I don't really support. So if we do support that, great, we can use this class factory. In fact, we can even stash it here just for better encapsulation, and we can return whatever the class factory has to say and say, hey, this class factory, go ahead and return it, whatever it has to say, by calling query interface, asking for this interface ID and PPV object, location for the return result, and return whatever H result is returned from there. Which reminds me, I think I've forgotten to implement query interface here. That's not going to work out very well for us. So we didn't implement query interface. Let's go ahead and do that. So for our class factory, we support two interfaces. IUnknown we always support, or we support the interface of creation here, which of course in this case is the standard one of iClass factory, which has been defined by Microsoft many years ago. So if someone is asking for one of those, great, we're happy to oblige. I'm going to put here static cast again, just to make it really precise with iClass factory, say, with this, and return as okay. I'm not even bothering calling addref here, because addref is doing actually nothing, just returning a fixed value, so no point in calling that. Otherwise, we have no interface here like before. We don't support that interface. And at that point, we're done with the class factory and how to get that thing from this function. But we're still missing a few things. For example, this function is not currently exported, so how can anyone find it? We have to export that first. And then we have to do a few more things, such as registering the DLL appropriately, correctly. So how are we going to do that? And since this video has become a bit longer than I expected, we'll see the rest of this COM server and an example client in the next video.